10 seconds. 10. 9. 3, 2, 1. Woo! Welcome everyone to 2020 and the React Denver meetup. How many of you have been here before? That's awesome. How many people are new? Who's awesome? That's a really good split. Welcome all you newcomers. I hope you've already made to feel welcome. We're really happy to have you. And next slide. And a quick note on logistics. We have salad and pizza. Looks like we're still going strong. We do not have cocktails, but we have plenty of soda. We are proudly a non-alcoholic meetup, but you're free to have drinks after this. Not here, somewhere else. In the bathrooms if you're new. In the bathrooms if you're new here, the ladies' room is right here. The men's room is sort of around the corner down the hallway. I think you can get to it that way. Otherwise, around the other side of the elevators. And there are at least 4 gender-neutral bathrooms right out there as well. What else? Next slide. Slides are so handy. All right, sponsors. So we wouldn't be here without our sponsors. First, I'm very appreciative to Turing. Any current or grad students from Turing? Yes, I know. Awesome. Thank you. We love Turing. They're an awesome venue, awesome hosts, and just the best place to have a meetup. Salt for supporting our lending, Salt Lending for supporting our meetup dues. Thank you. And tonight, I'm really happy to introduce Kara from Austin Fraser. Would you come up here to share a word? Thank you.
Hi, everyone. I'm Kara with Austin Fraser. Sorry, out of breath all of a sudden. We are a local tech recruitment firm. I am working only on React Angular roles, only in Denver, Boulder, only full-time. We work with a lot of startup to medium-sized companies. So if you are in the market for something new, I am working on a number of full-time roles. I've got my card right up here. It's Kara Ashley, like 2 first names, Kara with a K, Ashley with an A. Thanks.
Thank you, Kara. Please give it up for Austin Fraser and Kara. And as always, thank you to our Open Collective supporters. We do all our finances through Open Collective, which is basically a nonprofit that manages all this. Feel free to donate at any time. Next slide. And who is hiring? Who else is hiring? And if you're up here, you're welcome to come up and take the mic and just say a little quick bit about what you're hiring for. Anyone? Yeah, come on up. Thanks.
Cool. So I'm Kyle. I work for FluentStream Technologies. We are a better communication service for small to medium businesses. We're mostly React on the front end, and then we've got PHP, a little bit of Go, and lots of stuff. So for full stack as well, we're hiring junior all the way up to senior. So if you need a job, come talk to Cody or myself. We both work there. Yeah, and my email.
Thank you. Anyone else? Thank you for coming up.
Hi, my name is Mark Sang. I work for GigSmart. It's a fully funded startup, and we're doing basically, I would say Uber for people who are trying to find jobs. So if you're somebody looking to hire somebody or somebody looking to get a job, we provide the app that allows you to actually find each other. So we're hiring a React Native. I know that's not probably everybody's. We also have a React Native group for those who want to learn, and our backend is Elixir. So any Ruby devs who want to, upgrade your skills.
Thank you. Thanks. Anyone else? We're also hiring at Workday. I'm up in Boulder, so if anyone's interested, I'm not sure what we're hiring for right now. So just talk to me if you're interested in Boulder. Next slide. Announcements. Any other than the React Native group? Are there any other meetups or conferences or events happening that anyone would like to share? Cool.
Anybody from the GraphQL meetup? A lot of people going to that.
Yeah.
I think there's a GraphQL meetup next week.
There's a GraphQL meetup next week on Tuesday. Okay. At Gusto. Oh, you work there, so you know. Okay, cool. All right, so there's that. That's good to know. That's what I'm looking for. Anything else? Functional programming meetup later in the month. Look at meetup.com for it. Cool. Awesome. And this isn't an announcement so much as I want to take a moment. I've been an co-organizer for the meetup for a while, but I haven't been around, and I wanted to say thank you to the other organizers who have done an amazing job keeping this going. Sam Lindstrom is our lead organizer. He's done a terrific job. Please stand up. David Adams. And I think Kevin McKernan is up guarding the door, helping people in. Kevin's also amazing. And I also want to point them out as people that you can talk to if you're ever interested in sponsoring or speaking or getting involved in any way. We're always looking for people to help out. We have a couple new speakers tonight I'm very excited about. So I'd love to see every single one of you come up and share what you have to share at some point in the future. So we'd love to have you speak, amongst other things. Thank you. So with that, let's get on to our first talk on bridging the gap between old and new. I'm very excited to hear from our two new speakers to this meetup. Please give it up for Bethany and Eric.
Okay, you got me? Cool. Okay, should we do it again? Okay, hello everyone. My name is Bethany Mitch. My nickname is Beef, and that is what a lot of people call me.
And I don't have a nickname, so you can just call me Eric.
Boring, remember? Okay, so we are going to talk to you about bridging the gap between old and new, specifically without interrupting your clients on your product. So Eric and I are both software developers at AbsenceSoft. AbsenceSoft has built a platform that makes managing FMLA, short-term disability, and long-term disability leaves and ADA accommodations easy and compliant. Our headquarters is located in the Denver West area, just steps away from South Table Mountain. Eric and I, along with our team, have had the pleasure of trail running and mountain biking around the area, and even a little rock climbing in Golden. So it's a really fun culture and even more fun coding challenges along the way. So definitely keep an eye out because we will be growing within the next year. Along with our current product challenges, I'm going to hand that off to Eric in just a second. We'll then be going over bridging the gap and what that looks like, how we're taking our legacy code and moving it over to React. We'll give you a couple of demos and examples. And last but definitely not least, we want to talk about questions, comments, concerns, and feedback. This is an opportunity for us to give a huge shout out to Hotel Engine. We actually went to Denver Startup Week last year, and we went to their JavaScript Journey Talk. And we have actually implemented some tools that they shared with us at that conversation. And just a huge shout out to Hotel Engine and this industry in general. So that was super awesome. Eric, take it away.
All right, so I've been told I have to talk slow, and I had a lot of coffee just right before this, so that's going to go really well. All right, so at AbsenceSoft, our product is about 5 or 6 years old. It was around before React got really, really big. So we have a few challenges that we have to deal with, and a lot of people I'm sure have the same challenges. Our product is based in AngularJS, which is being sunsetted next year. We have jQuery and we have Razor files. And if you haven't used Razor files, they're kind of like C#'s version of PHP. They're server-side rendered files where they're actually taking information from our controller server-side, injecting it into a template, and then producing it, producing an HTML file that's delivering back to the server or back to the client. So for us, one of the things we ran into after she had talked to the people about the Hotel Engine about doing AngularJS and using Redux they actually found that I think they had a more of a SPA framework. And for us, we had a bigger challenge, which, well, in our mind, we had a different challenge. I shouldn't say bigger. That's a kind of hefty, it's kind of hefty to say. But we have a different challenge in my mind where we actually have to figure out how do we get information from basically a solution where we don't really have a whole lot of REST built in right now. Currently, our back end, they're building it out as we're building our front end, so we kind of have to figure out how do we get the information that we have in our existing product into the new React product that we're building out. So those were some of our challenges. We looked at a few things. One of the things we looked at were basically packaging it up with Webpack and trying to introduce ES 6, 7, and 8, and how do we bring all this Angular up to new stuff. And kind of one of the things we decided was to just leave it as is. So we took our existing application, and our first step was to kind of quarantine it off so that we could put it in a folder, put it where it was, let it live how it was living previously, and then build out our React in a separate project. So we kind of have them living side by side so that we can let Angular or AngularJS and jQuery, that project, kind of die slowly over time, and then build out our new React at the same time without letting our clients kind of have to deal with it in the middle of it. So we don't have the option of going and completely replatforming and turning on and turning off, so we're going to do it bit by bit. And Beef's going to talk a little bit more about that in a minute. So the first thing we're going to do is we're actually decided to use Redux. Redux, and I know a lot of people here are familiar with Redux, but Redux is not specific to React, and some people think that it is. Redux is actually its own entity. So one of the things that's nice about it is we were able to use ng Redux to basically build out our store in React and then access it through Angular. So I'm going to kind of show how we did that. So I wrote this last night, so bear with me. Don't judge me on my code. But it is a calculator. It's a place where I like to create algorithms.
This has nothing to do with my nickname, by the way.
No. And I finished this at like 2 a.m., so it's not the best code example. But I figured if we showed you our code, it's like thousands and thousands and thousands of lines long, and I would get lost and it would go horribly wrong. So I have my calculator here. So right now what I have is I have a white cow and a red cow, and it equals a pink cow, and I can swap out these different colors, and it generates colors that are, this doesn't work really well, but it works the best that I can. So if you're looking at this app right now, it looks like it's a single page. It's all one application, but actually this part right here, the calculator generation, is AngularJS, and it's using ES5. It's actually, I don't have the ability of using package.json with this because that's the challenge that we ran into with our current project is we couldn't really package it up. A lot of our stuff is hard-coded in, and it uses Razor files to bundle it up and then dump it into the server-side code. So there's a lot of things, and I'm happy to talk about it afterwards because I will start rambling otherwise and go off onto a tangent. So anyway, so if you're looking at this right now, this is right here, these cows right here are actually a React app. And if you look down at the bottom here in my Redux DevTools, as I'm swapping out colors, it's updating my store, and then React is finding that information and pulling it in and doing what it needs to do. So how do we do that? All right, so first things first. I have my ng controller here. This is my AngularJS. I have to specify that. What's that? Yeah. How's that? Embiggen more? Embiggen. All right, we've embiggened. We're good now. Okay, so we have our ng controller. And down here you can see, this, like I said, I literally jammed this together last night. So I have my React code jammed in here, and I have an Angular code, and then pulling in Redux and Redux, ng Redux also. So what am I doing? And this is kind of the thing. One of the things we wanted to do when we had this talk was open it up to maybe possibilities that other people have done something similar, and they may have better ideas how to do this. So I'm not saying this is the way to do it. This is how we're approaching it. So if I go in here into my React app, it is a pretty basic setup, except for one thing. I'm actually creating a global namespace on our window, which gives me the EBGBs, but I couldn't find a better way to do it after doing a lot of research. So we're creating a global namespace. It's window. On the window, it's called cow. Then we're creating our React store like normal, and I was planning on putting more reducers in here, but I just ended up with one. And then I'm actually sticking it on this global store. The reason I'm doing this is because if you create them separately in the two different apps, it has a really hard time finding them individually, so it creates two separate stories even though they're named the same. So I'm putting it on the window so that I can pass it off, and I kind of like to explain it as React is creating the store and Angular is renting it from React temporarily. So the idea is I want to be able to rip this out later on, so I'll actually get rid of this. When I'm done with this and we're done with Angular, we'll pull this code out and React will just keep moving on the way it was moving without actually touching it. So if I go to my Angular side, so you can see I've got my app here and I'm providing my store. Microphone. If I go into my app here, this is my Angular app. It's the Cowgorithm. It's going, it's got the cow controller, which I really regret that name. I should have called it like the ranch or something. So NG Redux, I'm injecting NG Redux into here. And then this right here is the key. This NG Redux provider actually, NG Redux has something that I didn't quite find in React Redux, and it might be there, I just couldn't find it. But it allows you to not just create a store, but allows you to ingest a store. So I'm using NG Redux, I'm providing that existing store that's on the window, and then we're injecting it in. And so if you've used Redux before, if you haven't, React Redux is actually a wrapper around Redux, and it allows you to inject the Redux code into your React component, so you can use it as props. So you can use something like map state to props or map dispatch to props. It allows you to inject your store and then basically consume it through a normal React way. NG Redux has a similar thing, so I'm actually able to map state to this. In this case, it's scope, if you've used AngularJS. So I can actually map state to it, and then I can call my actions, dispatch my actions, actually apply my changes and stick them into the store. What's really cool about this, though, is and I don't have, it's because it's embiggened. Oh, it actually worked out really well. Nice. So if you look at my app, I've got my React app here, and I've got my Angular app side by side. They're actually separate. They're not, the only way they're talking to each other is through React Redux. It's the glue, it's kind of the bridge for us. So what the nice thing about this is that, that if I look in here, the only thing I'm actually creating in Angular is actions to dispatch. Because it's using the same store, it actually will consume and dispatch, and then React will take over, and the reducers in React will do the work for you, and with your constants and your reducers, which is really nice because you don't have to duplicate code except for the actions. So it works out really well. I haven't tried this with other things, but I do believe this will work with jQuery and various other packages because of the nature of Redux. So that's step one for us to basically start moving over. So now that we have the glue, Beef is going to take over and start talking about how we move on from there. She didn't create a cow grader, though.
I didn't.
And I don't know.
There you go. So really that was steps 1 through 3. So now the next thing that is bridging the gap for us is that we have our current product. And looking at it, say, if you were on Airbnb, right? You look at Airbnb, you have your div of like stays, experiences, all these little boxes. So we found that very similar with our own product, right? We have different areas within our product that we can probably rip out and just componentize. So that's kind of the goal here. And our fourth step here was to make an AbsenceSoft component library. So we have a separate project going on right now where we're building out a bunch of reusable components. Think default modal, default accordion, your buttons, everything is going to be there, and we're going to live in Storybook. So our product and our design and everyone can take a look at it and update it as necessary. Another thing that we're implementing into our component library is unit testing, unit testing, unit testing. So we've actually been using React testing library with Jest. Our goal for this component library is actually to be 100% coverage, like all tested. So then that way we're going to take all of these reusable components, put them into our React app, style them as necessary, and then that's what will be shown on the Angular, onto our product. Cool? And again, component by component, and then that way we can utilize that Redux store. Just kind of an example of this. So again, on the left here we have our component library. We're also using styled components, so that is why our components are being pulled in this way. So we have modal, modal header, title, body, very, very basic default modal. And then on the right, we can bring into our React app, and we can bring in this modal, style it the way we need to for this specific customized component, our cow grader example. So we have this modal. the calculator. And we have a modal now, and now we can add more things into it, right? We have a container, a row. We've actually created this default table, and that also we have a separate table out into our component library. So we can just plug and play all day, and it's really fun. This past week, we actually implemented into one of our other custom components that we've been building. We put a default modal in there within like 45 minutes. Everything was already done. So that's been really helpful in just building out components and hoping to continuously build out reusable ones. And then this is a little GIF of my modal. So this is just the storybook that we're using currently. Right here, you'll just see this is 3 separate components. We have an icon, the modal, and the button, and it's all already built. So all you have to do when you import it into the React library is tell it what the title is, tell it what icon you want, tell it what color you want the button. Everything's already done. All you have to do is specify title, icon, all those things. So it's been a really fun project and really easy to implement for our future React Angular mix-up. Cool. So we've crossed the bridge, like a little bit.
So yeah, I mean, for us, it's going to be a long journey. We have a huge project to start taking out piece by piece. But our idea, our goal really in the end is we build all these things out, we bridge it so we don't have to touch the stuff. We don't want to introduce new defects into existing code as much as possible. But then on top of that, we're going to be creating this. And the React component library is going to be a powerful tool for us because, yeah, we can, a lot of the stuff you can get from third-party libraries, but we're going to be changing design after this is done. So we want to have complete control over that as well. So as much as we can build out, as much as we can test, as much as we can set up so that our designers later on can come in, we're actually theming it all too at the same time. As much as we can do that now, it'll make less work for us later on, and we'll be able to just check and make sure that all our tests pass and everything goes well. So, yeah. Yep.
Well, thank you all so much for listening. Again, we really want to welcome, I don't know how much time we have, any questions, comments, concerns, feedback that you have for us. But again, thank you so much. It's cool, we didn't want any.
No, we actually used create no, because it doesn't. It's kind of weird by the way Angular pulled in everything. I was actually surprised to get the actions to work. That was one of the big questions I had was how do I actually get these to talk because we were using it stored in. But the goal is React doesn't really talk back to the JavaScript I'm pulling in from Angular very well, but that's something that we're kind of curious how that's going to work out. But it is part of our build out for the package, the React component, because we want that to be completely separate, 100%. I don't want to have any ties into our Angular side as much as possible. So far, I haven't seen any conflicts, but that's going to be kind of something that we're going to be keeping an eye on.
Any other questions? All right, let's give it up one more time for Bethany and Eric. Cool, but before we get on to our next speaker, pop quiz. What do you call somebody who works at Formidable Labs? Yes, no, really, what do you call them? A singular would be a formidable. So somebody who works at Formidable is a formidable. Cool. You have formidable buddies? That's awesome. Well, we have somebody, a formidable, coming to speak and share with us in a few moments. I won't say much more than that, but he's amazing. And I want to invite anyone who's hungry to help finish off the food. We do not want to carry any more home. Grab a drink, hit the bathroom. We'll reconvene in like 3 minutes. Thank you. His name is up there. This is Chris Bolin. I'm happy to introduce from Formidable to talk about high-performance responsive images. Please give it up.
Thanks, Will. And thanks for that talk earlier. That was really fascinating, something I've just worked on a little bit, so that's cool to see. My name is Chris Bolin, and though I might look like the most responsible person working at a dispensary, I am indeed a software engineer like many of you. It's good, right? Came up with that today. I work for Formidable, and we do call each other Formidables. It's a pretty intimidating name, but I think we're pretty kind people. If you'd like to talk to any of my Formida buddies over there, you want to raise your hands? No, they're not all of them. There you go. If you're curious about what we do, we are a React and Node consultancy, so we build apps for other people based on a few core technologies, React being one of them, React Native, Node on the back end, and when we're lucky, we get to use GraphQL for a communications layer there. But I'm here to talk to you today about images on the web. This is my dog Harley, and whenever I can't find a more appropriate image, you're going to see an image of Harley. And she loves pillows, so usually she'll be with at least 2 or 3 pillows. So images are still very, very relevant for web development. Even though we have video, we have other types of media content, images are still by far the most prevalent. And the statistic that I've seen other people quote, and I've also seen in my own work, is that for a typical payload on a website, you'll have half of your payload be images. So the other half of the payload might be some fonts, but primarily it's a JavaScript bundle there, some other assets, but then images is a good half of all of that. So anything you can do to optimize your images or the way you interact with images is going to have a pretty big impact on performance. A lot of the work I've done over the last year and a half or so has been pretty performance focused. This usually comes from people using mobile devices and wanting a faster experience there. Mobile devices kind of are in a performance bottleneck in a couple different directions. They have the weakest processors and also the weakest connections to the network. So you could be on a 3G connection on an Android that's a couple years old, and that's going to be a lot weaker than my machine right here, connected via Wi-Fi. So usually when we start thinking mobile first, you start thinking about performance pretty quickly. And I also think that images can give us a really interesting insight into how the browser works overall. So I know at most meetups there's people from a wide range of experience levels, and I want any talk to be relevant for everyone involved. So even if you are newer to web dev, thinking about how the browser processes images I think can be really illuminating. So how many people are familiar with Chrome Lighthouse? Maybe this means I don't have to do a demo. All right, so anytime I think about performance, I reach for Lighthouse. This is a tool built right into Chrome. It's right in your DevTools. And I won't do a full demo, but I guess I can look at it very quickly, what results of a Lighthouse audit would look like. So sticking with the dog theme, here's Petco. And we have, in my DevTools, there's a tab called Audit. And if you click on Audits, you can run a Lighthouse audit. Kind of confusing naming. Now it's just like Chrome Audits, but it used to be a separate tool called Lighthouse. There are various audits you can do. Performance is the one most relevant for a lot of the work I do, but you can also look at, for example, how you stack up from an accessibility standpoint, or maybe even look at SEO, whether your site has been optimized for SEO. So I'm not going to run an audit right now because it might take like a minute. Really what it's going to do is it's going to kind of spoof a mobile phone connecting to this website, and it's going to monitor all of the web traffic, all of the rendering that Chrome has to do. So this is why it has to be a tool built into the browser, because it has to have specific knowledge about the exact steps the browser's taking. So Petco has done actually pretty poorly on its performance score. It's 11 here. Amazon's about 80 on the performance scale here. Most sites that I work with folks on are somewhere in that 20 to 30 range, and we're trying to push them up. You know, like Target is a pretty high-performing site. I'm sure you notice how great Target.com performs. But that's maybe similar to around 50. This is what I'll do. I'll be on a web page like, hey, I wonder how their Lighthouse score is. I just hit 100 on my personal one, which is a very, very simple portfolio, but it felt really good to see that 100, like watch this thing come all the way around. And so the nice thing about Lighthouse, and let me zoom in just a little bit here, is it's going to give you very targeted feedback. So you're going to look at a couple different metrics. If you've never done Lighthouse before, I would look at time to interactive. This is essentially the time that it's going to take a user, again, on this network and on this device, how long it's going to take for them to actually be able to interact with your site. And the way they measure interactivity is something called input delay. That's how long it takes from when I click on, say, a button or something with an event handler to when that event handler would respond. And they want to see that below 50 milliseconds. It should be snappy. And so this is, on Petco, they're going to estimate that on a 3G connection on a mobile phone, it's going to take about 22 seconds before someone can interact with the site. You get a pretty cool timeline there. And you shouldn't shit on Petco. Like, this is not that not that bad actually, like 22 seconds. Honestly, if you're below 10 seconds on a mobile phone, that's pretty speedy, especially with a full-fledged e-commerce site. So no way do I mean to talk ill about them. And then what Lighthouse is going to do is it's going to give you very targeted actions you could take, right? So the number one opportunity they say is you could save 3 seconds if you just eliminate some render blocking resources. What I'm guessing is happening is that it's a pretty large bundle coming down, and the browser's chewing on that, trying to process that, and it can't render at the same time. There might be some other things happening there as well. So it has those opportunities, and then it gives you a couple diagnostics on what's going on. In fact, this is a very common one you'll see in performance. It says reduce the impact of third-party code. That just means all of those trackers that like your marketing team might want to put up. Every time you add one of those trackers, you're paying a small penalty in your startup time. Cool. So Lighthouse is a very useful tool. Anytime you have to have a conversation about performance, probably reaching for a tool like that just to see the landscape, see what's going on. So let's say that images ended up being one of the major concerns. It wasn't a concern for Petco, but for a lot of sites, image is going to be a primary concern. So let's think about what makes an image both responsive and fast. So I want you to chew on that for just a second. There are a lot of things, a laundry list, and this is my dog underneath some laundry. Those are the jokes you can expect. But let's think about that. What would make an image setup be responsive and fast? Can anybody think of anyone? Well, luckily, we have one over here. What's your name, young man? Hi, John. Yeah, like what would be properties of an image that?
Yeah, you can tailor an image to be appropriate to the size of the screen.
I like that. That's pretty good. In fact, that just so happens to be. I didn't plant him, by the way. Although I should have done that. A lot easier. So I have maybe 8 or 9 different criteria I'd like to meet for the image setup to be responsive and fast and treat performance well, while also giving the user the best experience without regards to performance, right? They should see the correct image. But there is a solution that covers all of these, right? So as we're thinking through it, I want you to think of how you might solve these problems as we add more and more and more requirements. So the first one might be to get the correct dimensions for the viewport, right? We should deliver an image that fits on the screen. So you can be both too large or too small. If you're too small, you have pixelation, like our good friend Barack Obama there on the right would be a little too pixelated. If the image is too large, that's just wasted time. That's wasted bytes going over the network. And you're waiting for that on your phone, and you don't need that giant image. It actually gets resampled down. That resampling time actually is another penalty you pay, but it's pretty small, so we'll disregard that. But you either send an image that's too pixelated, too small, or too large and wasteful. So you can look at your the width of the client with just body client width. But there's another reason we want to think about how big the image should be, because we have to respect the device's pixel ratio. So people are probably familiar with the concept of retina, right? So you have like retina screens, like my MacBook here has a quote retina screen. Maybe my old monitor at home is not a retina screen. And this is the number, basically the number of actual device pixels per every CSS or JS pixel. So kind of confusing, because pixels aren't pixels anymore. But luckily, the platform we're built on top of, the web, it's very, very accommodating, and it actually abstracts a lot of this away. So this is one of the only times we really need to think about this. But you should know that the number of pixels on a screen is always greater than or equal to the number of pixels in CSS. So my phone, let's say it's like 375 pixels wide, right? It's actually twice that, because for every pixel on my pixel in CSS, there's 2 pixels on my phone. So there's a good illustration here on the bottom. Let's say you have a 2 by 2 pixels in CSS. If your device had a ratio of 1, there'd only be 4 pixels there. If it had a ratio of 2, that'd be 4 by 4 or 16. Or you could have maybe 36 pixels there if it's a DPR of 4. So the word retina really doesn't mean anything anymore. It's way too ambiguous. You either have 1 or, quote, retina, which could be any number of these, right? It could be 1.3, 1.4, 1.5, 2. This crazy one, 2.625 is Apple's Plus phones. I don't even understand how that works. I don't know how you take and you have a fractional pixel, but they're brilliant. They're smarter than me, and they figured out a way to make it work. So you have to accommodate for all of this. So any system we create, we have to be ready for phones to walk in and the new Sony to have a pixel ratio of 5, right? Something brand new. So we have to find a way to accommodate all of that. because users on a fast connection are going to want a nice crystal clear image because all their native apps have that, right? All the native apps are ready for that. And in my view, the web is an amazing technology, and we should try to keep up with those native apps, and we've done a pretty good job so far. Another thing we're going to want from our image system is we're going to need to accommodate for the different types of formats, right? So we can think of PNG and JPEG, but there's also a lot of other formats that now have better compression ratios, things like JPEG 2000, JPEG XR, and probably the one most people have heard of is WebP from Google. Now, the problem is that the different browsers have different supports for these. So one of the most common browsers, Safari on my phone, does not support WebP. So any system we have should be able to serve images in different formats, and the client code should accommodate for that. The reason that the formats are interesting to us is they can have smaller file size and higher quality for the same image. Right? So this is what like Pied Piper, the kids were working on in Silicon Valley, they thought they created like the perfect compression algorithm. WebP, it certainly seems to be a better compression algorithm for images, for example. We also need to adhere to the design. So this is an interesting problem, and I don't want you to brush it aside and think that it's the same problem we just talked about earlier when we need to conform to the viewport size. This is actually a problem we call art direction, and it means that different images are used for different screens. Not just different size of the same image, but a different image. So this is Bo, this is Barack Obama's dog. Remember Barack Obama? This is one of the things he and I have in common, is we both have a dog. And in this example, on a desktop screen, you would have a full picture of Bo in the White House lawn and the White House behind. But maybe on a smaller device, you just want to highlight the main feature, which is the dog, and you'd have a nice cropped image like this. Now you could get pretty crazy trying to use the same image and zoom in on different parts of it, but it'd be wasteful, and it doesn't really get after the design. If you go into e-commerce space, you're probably going to have a design that has some sort of sale text and things like that on it, and that text is going to move around as the device gets smaller. It might be embedded in the image itself, and you're going to want a different image. So I'm going to actually call these different images image variants as opposed to different image sizes, because they're kind of two different problems. And again, we need to accommodate those two different use cases in whatever image system we create. Our images should also be able to be cached on the edge. So if you're familiar with CDNs, basically a bunch of servers that you rent from someone, and they store your images or other assets there, and they come very quickly to your user's device. So in the illustration on the left, this might be the classic server case where you have one server or group of servers somewhere in the world serving all of your users. But in the edge situation on a CDN, you have CDNs, what they call co-located, or located anywhere around the world close to your users. So maybe there's one here in Denver, there's also one close to Washington, D.C., et cetera, all around the world, so you can get your images very fast. And the key here is that we need to make sure that we describe our images in their URLs that we're very verbose in the URL, so that that image can be cached and refetched. We'd also like the images to be able to be cached in the browser. So like I have said here, the fastest network request is no network request at all. So if you don't have to go to the network, if you could just find that image on your device, that'd be very convenient. Now, you might think, oh, how often do you really hit a case like this? It seems kind of niche. But let's just picture the case where you first go to a website in landscape orientation, right? So you need an image that's pretty wide here, maybe at least twice as wide as this image. And now you flip your phone, and the same image is displayed. Let's say it's the same variant, right? So if your system is dumb, it says, oh no, now my viewport is 375 pixels wide. I don't have an image for that, and I'm going to go refetch it. So your system needs to be smart enough to accommodate for cases like this, because you don't want the user to feel like the page is reloading just because they flip their phone around. And of course, any dev that goes to your page is going to change the device width and things like that, and it would be nice to accommodate for that as well. But this is something that real users would hit as well. We have ability to use the browser's cache using service workers. It's okay if you've never done that before, neither have I. But one way you can use the service workers cache is to add a request. You basically add a URL, it'll go fetch that, and then anytime someone goes to that same URL, it's already cached there in the browser. It's basically a proxy in the browser. It'd also be really nice if we could adapt to slow connections. So if a user's on a spotty 3G connection, it'd be very, very nice if they could get a downsampled image, right? If they get a low-res image, especially if we could go later on, when the user has a faster connection, swap out that image with a high-res one. Now we can actually look at what kind of connection type the user has in Chrome and some of the more modern browsers, but this really, we don't have enough support for this, and it's still an experimental technology. But you can go play with this sometime. Just go navigator.connection.effective-type, and you can see like whether Chrome believes at that time that the user has about a 3G connection, about a 2G, et cetera. So it'd be very nice if our system could adapt to that as well. Now, the biggest wrench in the machine comes with server-side rendering. How many people are familiar with server-side rendering? A little bit? Cool, and if you're not, we'll go into it a little bit to explain it. So this is probably the hardest aspect we need to address, is that our image system needs to account for the DOM being rendered on the server and then later on the client, which means that the server needs to be thinking in the exact same way. It needs to have access to the exact same information that the client does. So any sort of cute things we could do in JavaScript in the client might not help us out in the server realm, right? Like measuring the exact viewport, that might not work for us on the server because we don't have access to all that information. So I'll just explain very briefly what server-side rendering is so we understand it in a little more detail. So let's say you have a create React app. You just spin something up really fast, and this is what I would call a client rendered app, or client-side rendering in this verbiage. So in a client rendered app, you'll first have, there on the far left, you have the server sends a response to the browser, and that response is pretty thin. It's basically an empty HTML document, and inside of it is a source link to your JavaScript file. So the browser downloads the HTML, it sees that it has to download a JavaScript file, it goes and downloads that, then it parses that, it optimizes it, finally executes it, and during that execution of that JavaScript file, it finally starts building up a DOM, like building up the DOM that the user can see, and then at the end, now you have a page that's built for the user, and they can view it and interact with it. In a server-rendered world, there's a little bit more complex, but we're going to render on both the client and the server. So the server is going to, maybe in this case, run React, and it's going to render to a string, and it's going to send that string as HTML, so the DOM is in the form of HTML, to the browser. And then when the browser reads that, it can render it directly. It also has to go fetch a JavaScript file as well. It has to go through the same process we just did. But then when React renders on the client, it just renders over it, or what we would say hydrates the existing application there. And so that means that the user, for maybe a couple seconds, has a page that's viewable, but isn't fully interactive. You could click links, but maybe you can't hover over things or hit events, certain events in the browser. So we have these two different worlds, and in the server-rendered world, let's say our page that's built up over here finally has a link to an image, right? Well, that means that whatever logic I can use in the browser, I have to have access to there in the server. So if we start, you can run into like very strange bugs if you don't address this. So when I was working with my client, it wasn't an app for my dog, but let's just say it was. I saw a very strange issue where the same image was downloaded twice using the Chrome inspector, but it was two different sizes. Now I looked through the page, looked at all of the rendered DOM, and there's only one image there, and it was for the larger of the two images. And so I thought, why would the smaller image ever have been downloaded? It's never referred to in the DOM. And so when I looked through the waterfall, basically the timeline, I noticed that that image was always first, and it was always before the client rendering. So what it turned out is that the server had rendered that 800 pixel image. So when the browser parsed it, this first time it rendered an 800 pixel image. And then the client had more smarts, it had more intelligence, said, hey, this is a high-res device, we need to go get that 1600 pixel image. And so now I'm in a really bad position where I'm swapping images out, I'm wasting bandwidth, and I have a very confusing bug that's very hard to solve. And you could imagine cases where your cache is screwed up, where you actually have an image swapping out for a totally different image there. It would look pretty bad. So now we need to build a perfect image system to accommodate all of this. And we're all JavaScript engineers, so we could do this all, right? So we just need to, on the server, we just need to parse the user agent, and then we determine what kind of browser. And from there, I guess we could assume what kind of viewport widths we have. We'd probably need to look up the device pixel ratio, but that's probably just as easy, right? We just have this giant table of every device known to man, and we just have all of their pixel widths. And we need to guess maybe the device orientation landscape, or that might be a hard one, but we can get to that one. And then we just need to set a reasonable fallback for any new devices that come on the market and aren't in our lookup table. And then I guess that effective type, like seeing how fast the connection is, it's going to be pretty rough to guess. But but that'll just be in our to-do list. It's on the backlog. And then on the client, all we're going to have to do is we're going to have to create a service worker and then account for like the device orientation and viewport width. So that should be pretty easy. There's probably some things I left off the list. So one of our to-dos should be to determine more of the to-dos. But fortunately, there's a system that works better than this, and someone else did it for you. So instead of building your own, instead of building this in JavaScript, you can just use the platform. So if you're tempted to build a very, very elaborate system like this that seems like other people have hit the problem, go around and look, talk to some people. There's probably a solution out there. And the wheel has been invented in this case. The browser can do this for you. And it's been able to do it for a couple of years, but I still haven't seen widespread use of this. So we're going to use our favorite IMG element, the normal image element, but we're going to use different attributes in there. We're going to use something called source set as opposed to just source. And we're going to use the sizes attribute. There's also another element we can use called the picture element, and that's going to have two different children, a source element as well as our old IMG. And so I'm going to walk through a couple code examples on how you would do this. So let's take a full width image, the simplest case of images. This is the front page to Unsplash. Unsplash has beautiful photography you can use that's royalty-free. And they, like many places, have what I would call a hero image, right? It's running right across the device. And so it's full width. So if I use source set, so notice I have image, same old tag, but then I have a new attribute called source set. I'm going to list off 3 different URLs for different heroes. And I'm going to describe the path, the image URL, and then after that, I'm going to have a number followed by W, and that's the image width in actual pixels. So this is actual pixels as opposed to CSS pixels. So if you were to open up the image in Finder or whatever and you look at its dimensions, that would be the exact dimensions. And then you can also have a source as a fallback for IE11 if you support that. And what the browser will do then is it will say, okay, I know how wide this is. I know what image is closest to that because you just told me where to get the images and what exact size they were. So now I can determine what I need to load. Also, the browser can say, we're on a slow connection. I'm going to account for that, and I'm going to go get the slower image. Or the browser could account for, I've already cached a larger image that I can downsample just fine. I'm going to use that instead. So now the browser can take care of all of this. The browser has access to all of the information you needed, and this can be server rendered because you know all of these things at the server render time. So let's look at a slightly more complex example. I don't want to leave out the cat lovers, so here we are on Unsplash with cute pictures of kittens. And this is going to account for the situation where images are not full width. So let's say we have our source set here. This is the exact same as before. We're just saying where to get the images and what actual width they are. But then we need to give the browser a hint. And we'll talk about why we need this hint in a second. But the hint is going to say on certain device widths, our images are going to need to be a certain width. So let's, the case we're looking at here is a 2-column layout. So we're probably right here. We're on a medium-sized device, maybe under 800 pixels. And we're going to say each of those images needs to be 85 viewport widths wide. This could be in pixels. This could be whatever. Any CSS values are valid there. And the reason we need to give the browser this hint is because the browser needs to determine all of this before it renders anything. So as the browser is parsing the HTML document, it's going to turn that HTML document into DOM, right? They aren't the same thing. The HTML is just a description of the DOM. So it's going to parse the HTML. It's going to hit this image tag. It's going to see it as a source set. And it's going to, all right, I'm going to get ready to send off a request for an image. Let me see if this source set has some hints for me in sizes. It does, great. I can determine all those things because while it's rendering, it already knows what the viewport width is. It doesn't need to wait for rendering. So now you skip a huge amount of work, so the browser doesn't have to render, doesn't have to do any of that before it sends off this request. And your browser can handle dozens and dozens of requests in tandem. So parallel requests are no problem, but waiting for rendering to happen before you can request something is a problem. So never are we reaching in, we're not doing any sort of like measuring of the DOM or anything like that. The browser's taking care of that. This does create an interesting dependency on your design, so just be aware of that you'd have to know exactly what the width of your images would be. So there are very helpful image services that can serve as a key part of this this pipeline. And these image services, like Akamai is a good example. The project I worked on, we had Adobe Scene7, and they let you scale the images on the fly. So as a query parameter, you can say, I want this image, but I want it to have a width of 480, or the same image, but I want to have a width of 800, and it will go spin those up on the fly and then also cache them. So this is the most useful way to do what we showed before, as opposed to creating 7 different images, or honestly, it's probably more like 12 different images for image sizes for every image you have. A service like this would enable you to do it on the fly. Let's say you want to support different image forms. We talked about WebP and some of those things. You're going to use the picture element in this case with the source element underneath it. And so source, you can think of source as like a placeholder for an image, right? A placeholder for an IMG. And so it's going to say what kind of type the images are, and then you can have a whole source set. And again, this is probably multiple images, each with their own sizes. Those are all WebP. And then you can have your SVGs, for example. You could have another one for JPEGs, etc. And then again, I always have my fallback image there. She's so cute. All right, so let's think of that case, the art direction case we had with Bo Obama. So if we want to accommodate all of these different image variants, again, not the same image, just rescaled. It's actually a different variant. This we might call like a close-up variant. This is a wide shot variant. We can do that with picture again, and in this case, look at the source. So we're adding the source element, and then we have a media query. So we need to say, like, under which media query is this valid? And then we give it another source set underneath there. So you can see this can get, like, multiplicatively complex. And I don't have an example where you try to do everything all at once, because it is pretty complex. But this is code. You can do it once, and it should scale to everything you do. Now, I will say, please, please only use the picture element for art direction and formats. Don't be tempted to hard-code your sizes in there, in the media query there, and then do it. And can anybody think of why you wouldn't want to do that? So the key reason is that this doesn't accommodate for your device pixel ratio, right? This is just CSS or JS pixels. This is not actual pixels. And so to accommodate modern devices, you need to be able to use source sets. So you still have to go back and use source sets. That's why all of these still have source set under them. Now, of course, you're going to hit a few bugs if you go to implement a system like this. Safari, unfortunately, is kind of the new IE. There's a lot of jokes about Safari being a laggard. And in this case, I don't even know if I would call this a bug that we hit. It's basically a missing optimization. So they could be forgiven, but this would be nice if they fixed the thing. So Safari doesn't do a good job in handling an image that has both source and IMG. So basically, it doesn't have any optimizations for solving the tie. If you have, like, okay, this image has been declared with both a source and an image, I'll just go get both of those. And the reason is because the DOM is built up differently in the client and the server. I think this is another case where you can learn a little bit by diving in pretty deep, and you realize that the server is going to build up the DOM and then render HTML. The client is actually going to use the primitives document.createElement, right? And so it's going to do this all on the fly. And once you do something like append to a picture an image, instantly Safari is going to go fetch that image. It's going to say, I know you're going to probably want this image. I'm going to go get it for you. That's very nice. But they missed the fact that that same picture had sources appended to them, and those had overriding values. So to get around this, you have to do a couple different things. First, you have to nix the source from all browsers except the ones that need it. Actually need it, that'd be IE11. So we actually have a regex in our code that says this is a Trident browser, meaning an IE11 browser. If so, we'll add that source. If not, just leave that empty. The other thing, and this feels really gross again, is that you have to order your props in a certain way. You have to have your sizes prop literally before your source set prop, so that when Safari hits that source set, it knows there's already sizes on that element. So really, really small things. If you go Google this problem, you'll see there's a bug in the file to React, and that it refers to a couple long-standing bugs in Safari. So the one thing we haven't talked about is how to choose those image widths, right? I just had a couple dummy ones there. These are the sizes we ended up going with. I think this is really now kind of an art. You could go look at your analytics and see what sizes you had to accommodate for. Again, you have to be future-proof, so you have to try to accommodate for those new devices that are going to come out with larger pixel ratios. But we have everything from 320 all the way down to 2644, and this is basically like your maximum image width size. All right, so there's a lot of other things we could talk about with images. we never talked about lazy image loading, which is a big part of making images performant. You could talk about like how you resize images on the fly, how you could talk about off-screen images, whether you want to like greedily go fetch those off-screen images or whether you want to wait for the user to take an action. There's a lot of really cool techniques on placeholder images, like having SVGs that then like fade into a JPEG. But we only have so much time, and you'd go to sleep like my cute dog here. So I think the key takeaways, in case you missed it, are that images can have a huge effect on performance, that Lighthouse is a really good tool to use if you want to get an overall feel for your performance, and that if you want to accommodate for high-performing images, you really should use the platform. So use, again, the keywords here are probably source set, sizes, and picture. And you can go Google those after this and read some tutorials on that. And with that, I'd like to thank you and open up for questions. Anything? Yeah.
With the source set attribute and the different sizes, do you have the different sizes ready to go that the browser then fetches, or is it, I guess that won't happen, but changing the size depending on the source set attribute?
Yeah, so the question was, is the source set, is that predetermined or is it determined somehow by the browser? And it is predetermined. So that string you have for your source set, that should be one to rule them all, right? This is a source set that should basically be complete for any browser that would come knocking. And you need to determine that beforehand. You need to basically cover your bases, and then the browser comes to that. And that's what makes it very easy, because then it can be cached, and the same thing can be served to all of those different browsers, and then those devices determine themselves what image to get. They're just giving them an option. It's basically a menu, right? Source set is a menu you're handing them, and the browser determines what it would like to order, and goes and fetches that. I should have put that in. That was a better way of explaining that. Good work. Yeah, what's up, Kevin? You didn't like my repeating it? I did a good job.
Yeah. More of a funny trivia answer than a question, but the reason for the 2.65 on the plus size is on those phones it actually renders at 3x and then scales it down to the size of the screen. And so the 2.65 is the scaled down. It's super weird, and they don't do it on newer phones, but that's why. I know, it's like,
nice.
Thank you for doing that. So anyways, there you go.
That's awesome. Anything else? Yeah, what's up, John? Good to see you again, young man.
Oh, hello there. You said there was some rule about don't use the picture element, right?
Yeah.
Can you clarify that?
Yeah, let's go back to that, because it can be kind of confusing. And honestly, I don't expect you to fully. I just like you to remember it. Like, try not to abuse this. And even though if you don't know what abusing it means, if you're implementing it, you're probably reading a little bit more. So there are a couple different cases you'd want to use the picture element. So again, picture is an element that wraps multiple children. Inside of that, you have sources, right? And so you could have a source. So the correct ways to use it are what we have on these two slides. We have a source with types, and then that's a specific type of image type. And then you have a number of different images under the source set. Or you have different media queries, and then you have a different image variant, is the word I'm going to use, as opposed to sizes. What you do not want to use it for is you do not want to have a bunch of different sources just for the image sizes, right? You don't want to say, okay, for anything less than 800, I need to use image 800. And for anything less than 1200, I use image 1200. You don't want to do that. And the reason you don't want to do that is because it doesn't take into account anything else that we have, any of the other options. It doesn't let the browser it doesn't give it a menu, essentially. It doesn't let it choose what to do on a slow connection. It doesn't let it know what to do on like a high pixel density display. So that's kind of the gotcha there. It'll still work, but it won't work well. You like removed half of the optimizations we worked for. Yeah.
Do you find do you factor compression in to all this, like especially like with JPEGs, or like is what you did like most of the work, the compression is like not really that much of a payoff?
So compression certainly matters. Like choosing the wrong compression versus the wrong size, they would both be wrong, right? But like maybe the wrong compression, let's keep quality constant so that your designers don't get mad. But so you kept quality constant, but used the wrong compression, meaning you like used JPEG 100% quality, it would look great, but it's just going to be a giant file. That you could get bit way harder by that, even if you had all your source sets and everything factored in. So yeah, I think compression is still going to matter, but it is kind of a separate. It's decoupled. Now we've decoupled them, right? So you don't have to do a mapping between compression and connection type or anything like that. You've totally decoupled it. Now you can tell your designers, like honestly, designers will go fiddle with tools like Adobe Scene7 that create all these images, and they'll say, okay, here's my presets. I want a preset for like small devices, and it's going to have this with unsharp mask, and it's going to go basically downsample the image in certain ways. So those absolutely matter, and you need to test for that. And that's one of the first things you'd see on like a Lighthouse score is you'd see, oh my God, somebody put a full res and uncompressed image here, and that would be bubble right up to the top. And so yeah, compression still matters.
So how do you get the best of both worlds of getting the image type and while using the picture element and using the source set in the image tag?
Yeah, it's basically a combinatorially complex problem, but you literally have one that has type JPEG and then the image query, or sorry, the media query, and then your source set, right? So like you kind of multiply the complexity by 3, which means actually that interesting enough, your DOM bloats a little bit and your HTML delivered to the client bloats a little bit, right? Because you have all of these different things there. But it doesn't do it appreciably so. Those are just a few bytes as opposed to extra images.
So I have a question. Apologies if I missed it. But is it like rule of thumb, generally speaking, should you just try to stick with source set versus using a picture tag?
So you should only reach for picture if you really want to support extra image formats, or if you have an art direction case which calls for different image variants. So most likely, like an e-commerce site, there would be every page probably has a hero, and that hero probably has to adapt to different sizes. So you have one art direction case that has to be accounted for there, but all of your product images don't have the art direction case, right? It's still the same picture of a skateboard no matter what size it is. It's just a different, it's just scaled. So you probably have to use picture in that case. Just make sure you use it correctly, but for everything else, it should basically be free of that element, unless, of course, you want to support the formats. And honestly, like I'm not convinced that the image formats are worth it at this point because the 2 major browser providers don't have a shared optimal image. So Safari doesn't support WebP, and until we find one, it's probably not worth doing it. And there are really good articles on this, like MDN, of course, has like really good stuff on this. That's how I learned most things, was doing that. So now that you have, like, you're primed for this, you can go through and read that article, and maybe some of it will make a little more sense. Cool.
I really wanted to ask a question, but in the future, do you see that all this will become kind of obsolete because the server will know everything about the clients and just be able to serve up the right content?
Yeah, if there is a new spec, I haven't seen what's on the horizon, but I certainly think there could be a spec that would take care of this. That in the request for the image, it would basically add metadata, and then the browser could determine from that metadata, right? Like, picture that if I had, if I have dog landscape, and then the browser actually adds on query params that describe exactly what it needs. That would be an ideal case. I just haven't seen that happen yet. Yeah, I mean, you could probably build like a toy example with like a Chrome plugin or something that would do it. But yeah, I hope that's the case. And I hope server-side rendering dies. I think a lot of these things will like simplify in the future. They will become obsolete. But for now, and for at least a couple years, this is what we got. There are also probably going to be good abstractions built on this so that it's a little bit simpler to use as well. I haven't seen an abstraction I like yet. Most of them get really mired in like lazy loading and other things. So I think for a couple reasons, hopefully we don't have to worry about this. Cool, I'll let you go, but you can still bug me afterwards. Thanks all.
Thank you, Chris. Before I let you all go and disperse, I want to say again, we're always looking for sponsors and speakers. And a couple thoughts on the speaker bit. It could be you, it could be a friend or colleague that you encourage. You also do not need to be as expert as the speakers we had tonight. Your talk does not have to be 30 minutes long. It could be as short as 5 minutes. So we'd love to hear from you. Thank you all for coming. Feel free to hang out, finish the food and drinks, and be awesome. Thanks.